Hello students, good evening. Welcome to another video of Vedantu, Karnataka. This is Catherine, your physics master teacher. Can you quickly let me know if I am audible and visible? Yes. How are you all doing? Right? Yes. Yeah. I am audible and visible, I believe. Students, quickly mark your attendance. All of you quickly go like the video, quickly mark your attendance so we know that you are here in class. Okay? So let's look at Sunita, Gaudru, Shivani. Hello, Shivani. So today we're going to do first PU. Where are all my first PU kids? We have done a first PU class last week. So today we're going to do the second chapter of first PU. Hi, Monster Gang. I'm good. How are you? Hi, Gautami. Hi, RXBTCC. I'm doing good. How are you doing? Hi, Vaibhav Venkatesh. So all those who have not subscribed to the channel, please subscribe so we can chat, okay? Yeah. Hi Sanket, hi Rohit. How are you all doing? Are you all doing well? How's your first few lessons going? Thank you so much, Nagappa, for continuously seeing my classes, okay? All of your motivation and support means a lot. Uh, yeah. I already said hi Sanket and hi Rohit. Okay? So I hope you're all doing really well. Did you all watch the video of chapter 1? Units and dimensions? Thank you, RXBTCC. RXBTC says that I'm so far the best physics teacher is he or she, I don't know. What is your real name, dear? Thank you, Rohit. Today we are going to do first PU, second chapter, motion in a straight line. Yes. So all of you, I want you to send the link to all your first PU friends. Send it in all your class groups. Tell them we will start with motion in a straight line. And all those who haven't watched units and dimension, which was the first chapter, I have finished it in a single video. It's there on the Vedantu Karnataka YouTube channel. So please go watch that as well. Today we're going to start with the next chapter, which is motion in a straight line. Motion in a straight line is a long chapter, so we will do it in parts. So today is going to be part 1. Okay? Thank you, Naina. Okay? Yes? Okay, RXBTC is a he. Okay. Alright, so let's start. If you're all ready for the class, can you quickly put some fire emojis in the chat so we can start? Quickly. And mark your attendance. 19 people have voted, but have 19 people liked the video? No, only 8 people have liked the video. Where are the others? Quickly like, subscribe and share it to all your friends. Students, if you're looking for offline classes at Vedantu, and if you're in Bangalore or anywhere in Karnataka, we have a new center for you. It's because we had a lot of students inquiring, we decided to open an offline center at JP Nagar. Okay, and if you are like confused on if you want to join or not join, you can feel free, book your visit, go talk to them, and if you feel like you want to join, you can join. Otherwise, you don't have to. Just go book a visit and go talk to the best faculties there. We have all faculties from top IITs, NITs, and all teaching you there. Okay? So, how do you book a visit? There's a link in the description. There's a Google form. You can just fill it and book a visit. That's all. It's as easy as that. All my smart students learning physics, won't have trouble doing all these, small things. Okay. So, seeing all. Thank you, Chaitra. So let's start with the class. So as I said, today's chapter is motion in a straight line. Motion in a straight line. I'm not even able to write this on a straight line, but yeah. So today we're going to discuss the chapter motion in a straight line. Okay. So first thing, when we look at motion in a straight line, you have to know what is motion. All of you might know what is motion, but if there's at least one person out there who doesn't know what is motion, let's discuss what is motion. What is motion? Motion is when something changes its position with respect to some amount of time. Okay, so now I am just staying still. My hands are in motion, but as whole, I am not moving. My head might be moving, but I am not moving. So I am not in motion. But if I keep moving, then I am in motion. So if my position changes with respect to time, then I am in motion. Okay, so imagine in 1 second I'm here, after 5 seconds I'm here, after 10 seconds I'm somewhere else. So I am moving. Okay, so in simple terms, what is motion? Motion is the change of position with respect to time of any object. I can give you some simple examples. A car moving on a road. The fan. If you're sitting in a room with a fan, the rotating fan, it's in motion because it's continuously moving. Okay, the earth moving around the sun. All these are examples of motion. Alright? Hi Khalil, Basha, P. Welcome to the class. Yes, Naina, yes, that's right. That's the correct definition. Naina has given a very good definition. Very good, Naina. Okay. Now there are different kinds of motion. There's translational motion, there's rotational motion, there's oscillatory motion, different kinds of motion. See, what is translational motion? When I am moving from one point to another on a straight path. Okay? Or if this is a track, there is a car. Okay? I'll just draw a car. Okay, this is my car. Okay? I'm not an art teacher, so my drawing is really bad. Okay, this is a car. This car is moving on the road from point A to point B. It's moving along a straight path. That is translational motion. Okay. Now, what is rotational motion? Rotational motion is when something is rotating, like your fan, or you might have seen the top. That top. I don't know what it's called in Kannada. So you have a top, and then it just spins. There's a point, and then it just spins. So all those are rotational motion when some object rotates with respect to an axis. So it will have an axis, and then it just rotates. Okay. So that is rotational motion. Oscillatory motion is a simple pendulum. So you have something hanging and then it just oscillates like this. Okay. So this motion is called oscillatory motion. Is that clear? So we looked at what motion is, and there are different kinds of motions. Translational along a straight path. Rotational, it's rotating along an axis. Oscillatory, it's moving back and forth, to and fro. Okay. Now, if there's motion, then there's obviously something opposite to that. What is it? Rest. Okay. If an object is moving from one position to another with respect to time, it's in motion. But when is an object in rest? When it does not change its position with respect to time. Okay. So right now I am at rest because, see, even for the whole class, if you look at the whole class, time will move, but I will not move. I'll still be here. Yes. Only after I end the class, I will move. So I am at rest because I am at the same position with respect to time. Even after 20 seconds, if you look at me, I will still be here. Even after 1 hour, I'll still be here. Even after 3 hours, will I still be here? If I'm still here after 3 hours, you'll start crying. Ma'am, please stop the class. No? Okay, I won't be here for that long, but I am not moving because even after so much of time, if you look at me, I will still be here. That means I am at rest. Okay? What does that mean? That means that the object does not change its position with respect to time. In very simple words, how can you say? An object is at rest when it is at the same place and it does not move. Then it is at rest. Okay? It just does not move, then it is at rest. I can give you an example. A book on a table. See, if you don't move the book will be there forever. Just like right now you're all in first PU, right? So your 10th standard books, those who have not sold your 10th standard books, they're all at rest at home. You don't take them. Why should you take them? So they're all at rest and they will remain at rest forever until your mom decides to clean the cupboard or something. They will be there forever. Okay? Yeah. So that is an example of rest. Yes, RXBTC, spinning top. What is that called in Kannada? Now, since you're first PU students or second PU students watching this, just rest and motion is not enough. You need to know that rest and motion are both relative concepts. What does that mean? That means an object can be at rest with respect to one observer. It can be in motion with respect to another observer. What does that mean? Imagine all of us, okay? Me and all of you, we're all going on a bus. Okay, there's a driver. All of us are sitting inside the bus. Now, if I look at you, you're also in my bus. I'm also in the bus. If I look at you, both of us are at rest. Isn't it? The driver is also at rest because we're all sitting at rest inside the bus. But if, say, one of your friends from the other class, he's standing outside, okay? He's standing at the bus stop and he sees you going in the bus. So, according to him, you are moving, isn't it? But according to all of us sitting inside the bus, we are all at rest. But when a person from outside looks at us, he thinks that we are moving. So, rest and motion, both of these are defined with respect to a reference. Okay? So, when you say you are at rest, you should say with respect to the bus, you are at rest. Now, if you're saying with respect to an observer outside, you are in motion. Okay, so rest and motion are always defined with respect to a reference. So, for example, with respect to this chair, I am at rest. But if you look at with respect to the earth is moving, so obviously I am also moving. So, it all depends on your reference. Okay, now imagine I'm sitting and taking this class in a car. I am still at rest with respect to all of you looking at me, I'm still at rest. But with respect to the car, I'm moving. You understand that? So you always need a reference. Yes? Photo is looking blur. Now is it clear? Yes. With respect to the universe, we are all in motion. Why? Because the earth is continuously moving. Okay? But if you look at with respect to your house, you are at rest. So it all depends on your reference. Is this clear? Oh, it's called Girkila. I don't know if I'm pronouncing it right, but yeah. Yes, Shivani, very good, very good. Muttamma, can you see it now? Can you see what is written now? Yes. Okay. Is this much clear to all of you? If this much is clear, okay, it's clear to Muttamma. Okay. Now let's start with the main portion for today. That was just a small introduction, a small basic introduction. Okay. You might have learned that in your previous class also. So before we go into real intense physics, I'll give you some, ice breaking session. That was what was over. Now we're going to start with today's main portion, which is kinematics. Now, what is kinematics? Kinematics is basically the study. Now, let's not say study. It's basically motion. Okay. So, kine stands. So, kine stands for motion. Okay. And matics stands for maths. So, what is kinematics? It's the study of how something moves by using some mathematics. Okay. So, I can say I'm walking straight, but using kinematics, I can say how I'm walking straight, in which direction I'm walking, at what speed I'm walking, at what distance I'm walking, how much time I take, all the mathematics I can include. So, motion with mathematics combined together is kinematics. And in this chapter, we will be looking at kinematics. Okay. Now, there are different kinds of motions. There is motion in 1D. Motion in 1D is just, linear motion. So, if I'm just walking on the ground, it's just 1D. What is motion in 2D? Motion is in 2D is when there are two dimensions involved. Okay, so if an object is moving only along the x-axis, this is 1D. Now, imagine there's an object moving like this. So, it's moving along the x-axis and the y-axis like projectile. Then this is 2D. Now, if an object moves along all three axes, just like a gas in a box, if it moves randomly in all the directions, that means it moves along x-axis, it moves along y-axis, it moves along z-axis. If it moves along all of these axes, then you can say it is three-dimensional motion. So in this chapter, which one will we be looking at? We will be looking at motion in one dimension. Okay, so only of x-axis. Mainly we are going to look at motion in one dimension. Is that clear? Hi Prajwal, welcome to the class. So all of you, please quickly share this link to all your first PU classes. All the second PU students who are watching me, send it to all your juniors so that they also learn. Okay, as I always say in all my classes, we are a community, we are a family, and we all learn together. Okay, we should keep on adding more members to our family. So every time you spot a PU student or a CBSE student or any student in 11th or 12th preparing for KCET NEET, tell them there's a channel Vedantu Karnataka and let them join to our wonderful family. Okay? Yes. Okay, so now we're going to start with kinematics. So the first thing that we're going to look at is, so under kinematics, motion and mass together, if you look at, there are so many terms. So there is distance. Distance comes under kinematics. And then there is displacement. This also comes under kinematics. And then there is speed. What else? Velocity. Then you can say acceleration. Then there is jerk. So all of these are all these come under kinematics. Okay, so these all include motion and some math behind it. Now in this, initially what we're going to learn is we're going to learn about distance, displacement, speed, velocity. We'll learn about all of these, but we'll start with distance and displacement. Okay, now what is distance and what is displacement? So I have some content here, but let's just learn what is distance and what is displacement first. So imagine A is your house, B is your school. Okay, so A is your house, B is your school. For all of, imagine, okay, A is your house, B is your school. Now there's a shop somewhere in between, so you go to school like this. Okay, but some of your other friends have to go to some other shops, so what they do is they go to school taking this path. Okay, but then there's one student, he's very studious, he just goes to school, comes back, he doesn't do anything in between, so he goes to school taking this path. Okay, so there is the first path, second path, and third path. Okay, these are three different paths to reach your school. So A is your house, B is your school, and there are this is the path. These are different ways you can go to reach B. Okay. Nagappa, what's your doubt? Total path covered by object is called distance. Yes, it is called distance. Total path. Hello. Hello, Toxic. Yes, it is called distance, dear. Nagappa, what is your doubt? Okay. So, yeah, is this much clear? Now, here, path 1, path 2, path 3, there are three different paths which have three different distances. Okay. So whatever the length is, it's all the distance. Path 1, path 2, path 3 are all distances from A to B. But what is displacement here? Displacement is the shortest possible distance to reach from point A to point B. So in 1, 2 and 3, which is the shortest? Obviously, it is path 2. So path 1, 2 and 3, all three show distance. But path 2 is the displacement. Why? Because it is the shortest possible path an object can take to move from one point to another. So from this you can say, is distance, okay, what can you say? You can say that distance will always be either greater than or equal to displacement. Can I say that? Yes, can I say that distance will always be greater than displacement? It's never going to be same. Yes? I mean, it's going, yeah. So if you take path 2 can be distance, path 2 can be displacement as well. So distance can be equal to displacement. But path 1 is distance. It's obviously greater than the displacement. Path 3 is also distance. It's obviously greater than the displacement. So distance is always greater than or equal to displacement. Okay? Yes. Hi Sai Kripa from Kolar. Welcome to the session. Hi Sridhara Sri. Yes, Shivani, the answer is second path. Very good. Okay? It is the second path. So what is displacement? Displacement is the shortest distance between the initial and final position. But what is distance? It is the total path or length traveled by the object. Okay? Is this clear? Now let's look at some questions. So we'll look at some questions. So first question, some application questions that will help you understand what's distance and displacement. So imagine there is a semicircular path. Okay, this is sports track. It is semicircular. This is A, this is B. This is A is the starting point, B is the ending point, and this is the path. Okay. Now this is part of a circle which has a radius of R. Alright. The radius of the circle is R. Now, find out the ratio of distance by displacement. How will you do that? Quickly, tell me how will you do that? I have to find out the ratio of distance by displacement. How will I find out the distance? The distance is obviously what? The circumference of the circle. Yes. So what is the circumference of a full circle? A full circle has a circumference of 2 pi r. Yes, we've all learned that. Full circle circumference is 2 pi r. So half circle circumference will be 2 pi r by 2. 2 pi r by 2. The whole divided by. What is the displacement? Displacement is the shortest possible path. And what is the shortest possible path here? Isn't it this path? So if half is r, the rest of the half will also be r. So it will be r plus r, which is 2r. Okay. Now this is going to be equal to pi r by 2r. So this will be pi by 2. Do you all understand this? Yes? No? Yes. Yes, Rajesh. Sorry, Rajesh is Sai Kripa. Sai Kripa, yes. Oh, Chaitra is from Mumbai. Okay, very good. Welcome to the session, Chaitra. Please tell all your Mumbai wala friends to subscribe and like the channel. Okay, send this in your class groups as well. So hi to all Chaitra's Mumbai friends. Okay, we have people from Mumbai. We have people from Kolar. Where are the others from? Is this fine? Clear? The difference between distance and displacement. Okay, now I'll give you another example. Let's look at another example. Let's say I have a cube. Okay? So there is a cube. A cube. My cube looks good, no? So my regular students know that, a picture at least this beautiful is a big task for me. I know this is not beautiful, but yeah. So let's say there's a cube and there's a diagonal from A to B. Okay? This is A, this is B. Okay, there's a diagonal from A to B. Now, the distance is from A to this point, all the way till B. Okay, so this is the distance. So, it's all A, A, A. Now, the displacement is obviously along AB. Now, I have to find out the displacement. So, distance is, no. Let me find out the displacement. Distance is just A plus A plus A. So, I have to find out the displacement. How will I find out the displacement? So, what I will do is, see, this is along x-axis, y-axis and z-axis. So, at this point, at point B, the coordinates are going to be AI cap plus AJ cap plus AK cap. Isn't it? Isn't that the coordinates at B? Because it is along x-axis, y-axis, and z-axis. So it's going to be ai cap plus aj cap plus a cap, a k cap. So AB, the magnitude of AB will be square root of a square plus a square plus a square. So this is going to be equal to square root of 3a square, which is going to be equal to square root of 3 into a. So the displacement will be square root 3 into a. Is that clear? Yes. Yes. Root a, is it root a cube or a root 3? Tell me, let me know if you're all getting this answer, students. Are you all understanding this? This is a root 3. Yes, Sai, can you let me know? Others also. Chaitra, Shivani, Nagappa, Toxic. What other students in class? Muttama, Naina. Let me know if this is clear to all of you. Did you understand this? So the distance is A along x-axis, so AI cap, A along y-axis, so AJ cap, A along z-axis, so AK cap. So AI plus AJ plus AK is the actual length of AB. Now I find out the magnitude by simply squaring all the terms. Okay? Okay. Let's look at one more example. I will look at one more example so you clearly understand. So now students, why I'm doing these examples are because some of you are going to prepare for your competitive exams. So when you go for competitive exams, conceptual understanding is very important. Yeah, so right now you might not be in a plan. You might be like, I don't know what I should do in my life, ma'am. I was also a student just like you. Okay. So that's why right now you should prepare for both. So, after when you enter first PU, if you feel like, okay, now I'll start preparing, you haven't lost any portion from first PU. Yeah. Okay, because you have been prepared in the way where you can write your PU exam or CPSE exam as well as competitive exam. That's why Vedantu classes are very good. Okay, because we train you for both your college or your school and your exam. Okay, next question. What color? Let's take blue. Okay, so I'm going to take a circle. Okay, so circle. Now there's a running race. I start from point A. Okay, I run all the way till point B. So this is my distance from A all the way till point B I run. Now, this is the center of the circle. So this distance is R, this distance is R. R is the radius of the circle. Now, what is the shortest possible path for me to reach B? What is my displacement? It's obviously this green line. Yes, so the green line is displacement. Now the question is find out the displacement. So let's find out the displacement. How will I find out the displacement? I can use the very famous Pythagoras theorem because this is a right angle triangle. So hypotenuse square. So hypotenuse square is equal to r square plus r square. So hypotenuse square is equal to 2r square. So hypotenuse is equal to square root of 2 into r. So hypotenuse is basically my displacement. Okay, I'll just put it as displacement. I'll put it as d. So you are not confused. So displacement is equal to r square root of 2. Is that clear to all of you? Yes? No? Atar? Yes, I'm good. How are you? Hello, Preetu. Okay, is this clear to all of you? I know in the chat. Okay, now I'll give you one more example. This you will have to do. I think I should give this to you as homework. And in the next class, I should look at the chat and look at the comments for your answer and then call out and give a shout out to you in class. How's that idea? Do you like that idea? So next running race, I run from point A to point B. along this distance. So what is my displacement? It is here. So these circles are all the same. Okay. So the radius is r. This is r. So what is the value of my displacement? Quickly, within seconds, tell me the answer. So here displacement will be, distance is obviously half of the circumference. Displacement will be, quickly, first person to tell me the answer. I can't give you anything, but I'll just call your name and say good job. 2r. Very good. Sai. Good. It is r plus r, which is 2r. Superb. So Sai is the first person to answer. Very good. Yes. Okay. So the displacement is 2r. So this is how you find out the relationship between distance and displacement. So do you understand? So you have to reach, you can reach 2 points from one point to another in multiple ways. But displacement is always the shortest way that you can reach. Okay. I can give you one more example. A little more, tougher example. So let's say there's again a circular path. So someone runs from, let's say Sai runs, okay? Sai, since Sai gave me the answer, Sai runs from point A to point B. Sai is an athlete, okay? Now, this is the distance. And this is R. This is R because it's the radius. Any point from the center will be R. What will my displacement be? My displacement will be this red line. Isn't it? So this is going to be my displacement. How do I find my displacement? Now I also tell you that in the question. Let me draw a better, I think I should do a better job. 1 second. Okay. AB. Yeah, this is my displacement. So now I tell you that this angle is 120 degree. Okay. So this angle is 120 degree. Hmm, 120 degree. Where do I put it? Yeah, it is 120 degree. Okay. Now I have to find out the displacement. How will I do it? So let's do it. First thing, I need to find out the base. This is not a right angle triangle. So I cannot be using my Pythagoras theorem. Okay. This is not a right angle triangle. So what will I use? What I can use is I can use resultant. Okay. So if this is R1 and this is R2 at an angle theta. Okay. And I need to find out D, which is the base of the triangle. Okay. This is R2. R1, R2, and then the base of the triangle. Okay. So I will get, so look at vector addition. So the tip, so this is basically R1 plus D is equal to R2. Why? So this tip and then the base and the tip. So the resultant will be like this. Triangle law of vector addition, I hope you've all learned. So this is A plus B and that will be C. Okay. So that is how you have to look at the arrows. Okay. So the head of the arrow should meet with the tail. So this is A, this is B, A plus B. So this is R1, this is B, R1 plus D. This should be equal to the resultant, which is R2. So only for the resultant and the second term, the heads will come together. Okay. So from this, I can write D is equal to R2 minus R1. They're all vectors. Okay. D is equal to R2 minus R1. Now what will the magnitude of D be? The magnitude of D will be R1 square plus R2 square minus 2 R1 R2 cos theta, because they are both at an angle. Now R1 and R2 are the same. They are both radiuses of the same circle. So they have the same value. So this is going to be equal to R square plus R square minus 2R square cos theta. So this becomes 2R square minus 2R square cos theta. So this will be square root of 2R square 1 minus cos theta. Okay. And this is something that you should know as a student of Sec 1st PU. 1 minus cos theta is equal to what? 2 sine square theta by 2. Mathematical identity. Yes. So this is going to be equal to 2r square 2 sine square theta by 2 and the root of the whole thing. Okay. So this will be 2 and 2 becomes 4, r square, everything has a square. Okay. So the square root can be just removed or eliminated. So what does it become? 2r sine theta by 2. This is the displacement. Now what we can do, we can substitute this in our question. Okay. So in our question, I'll just remove this. So in our question, displacement is equal to 2r sine theta by 2. So this is going to be equal to 2r sine 120 by 2 is 60. So sine 60 is root 3 by 2. So 2r root 3 by 2. 2 and 2 cancels. So this is r root 3. Do you understand this? R square root 3 by 2. What happened, Sai? You have a doubt somewhere? Yes. You have a doubt somewhere? Sai? Anime fan. Hi, anime fan. Can you quickly let me know in the chats, all those who are listening to my class, if this is clear? So what I've written in blue is a general way to do it. Okay, and that formula I've substituted because in my fifth question, I have my angle as 120. Okay. You are not understanding vectors. Okay, so all those who are not understanding vectors, I'll teach you vectors, don't worry. So if you have a vector, okay, you have a vector, let's say this vector is A, okay, the next vector, this is the head of the vector. This arrow part should be the head of the vector. The line part is the tail of the vector, okay. Now, this vector, if I want to add it with another vector B, I should put vector B like this. So the tail should be at the head and then the head should be opposite. So this means what? This means A plus B. Okay. So if you have two vectors like this means A plus B. Now if I want to find out the resultant, if I want to draw C, how will I draw it? I should draw it like this. So the head of the vector and the head of the vector, they should meet. Is this part clear? Okay, it's clear for anime fan. Anime fan, some of the others have doubts. Okay, yeah. So I can give you another example. So let's say this is A. If you want to add B to it, you should add it like this. So the resultant will be C. Okay, so same thing I'm going to do here. What I'm going to do here is, let me erase this also. Okay, what I'm going to do here is, I'm going to take my first vector R1. Okay, now I have another vector R2 here. But I can't add R1 and R2 because their tails are meeting. So what I will do, I will add R1 with the displacement vector D. Okay, and then I will take the resultant as the answer as R2. Okay, so this is basically R2 will be equal to R1 plus D. That is what I've written here. First step, R2 is equal to R1 plus D. Vectors. Do you understand this part? Okay. Next is how will we find out the resultant of two vectors? So if R2 is equal to R1 plus D, then how do I find the resultant, which is the mode or the value of R2? That's the next part. If this much is clear, then we can move forward. Is this much clear to all of you? Okay. Now what I'm going to do, I'm going to rearrange it because I want D. That's why you can write it in terms of R2 also, but because I want D, I'm just going to do R2 minus R1. Okay. Now, whenever you have two vectors, okay, that is you need to know that formula. If you're giving the magnitude and the angle, okay, if there are two vectors at an angle theta, then the resultant is always given as, okay, if these two vectors are A and B, it's going to be A square plus B square plus 2AB cos theta. Okay, so if you have two vectors at an angle theta, then the resultant is given by A square plus B square plus 2AB cos theta. Is that clear? Yes. So now instead of R, A and B, I will write it in my equation. So D will be equal to square root of R2 square plus R1 square, R2 square plus R1 square, and there is a minus. So the minus will come here. Minus 2 R1 R2 cos theta. This is my general formula. Now, see, this R1 and R2 are both radiuses of a circle. So they are the same. So R2 and R1 are the same. So now what will be D? It will be, I'll just take it as R. Okay. So R square plus R square minus 2R square cos theta. Now I take all the R squares outside. It becomes 2R square. What remains? 1 minus cos theta. Yeah, 1 minus cos theta. Okay. Now what is 1 minus cos theta? That I've already told you. 1 minus cos theta is 2 sine square theta by 2. Mathematics, trigonometry. You've learned these identities. So this is going to be 2R square root of 2 sine square theta by 2. So this is what? This is 4R square sine square theta by 2, the square root. So when I just remove the square root, this becomes 2R sine theta by 2. So this is a general formula for displacement. Now I will use that in my question. So in my question, in the question itself, it's given that the angle between the two is 120 and the value of the length is R. So R will become R itself, sine theta will be by 2 will be sine 120 by 2, which is sine 60. So that's how you will get 2R sine 60. So this will be 2R 3 by 2. So it will be R root 3. Now is this clear to all of you? Can you all let me know in the chats? If it's clear, please write clear in the chat. Yes? Okay? I think I've explained it properly. Now students, if it was, D is equal to R2 plus R1, then the magnitude will be R1 square plus R2 square plus 2R1 R2 cos theta. Okay? It's clear? Shivani, Sai, both of you had the doubt. Here I'll just put C. Clear. Okay, it's clear for Mahi. It's clear for Prarthana. Okay, very good. Let's move on to the next question. Okay, so after all these questions, this concept will be very thorough to all of you. Okay, let's move on to the next question. A wheel of radius R is rolling without slipping on a straight road. Okay, so there's a straight road and then there is a wheel. This wheel has a radius of R. Okay, So the wheel of radius r is rolling. It is not slipping. What would be the displacement of a point P on the rim of the wheel after half a rotation? Okay, so imagine it's the wheel rotates from, let's say, point P, okay, half rotation. So that means this, I should have had something like a wheel. Okay, I have something like a wheel here. Okay, let's say this is my wheel. Okay, right now this is point B. This is the base. Half rotation means this point should reach the ground. That's all. Like this, right? Yeah, like this. Okay. So half rotation is when this point should reach the ground. So it should be this. Full rotation is when the whole thing rotates. But half rotation is when this point P, okay, this is the top point. The top point reaches the ground. So it has done half rotation. So after half rotation, what should happen? What should happen? Point P should be up. So let's say this is P dash. So that's how when it is half rotation. Okay. So now P and P dash are the same points. Okay. So if this was P, after one rotation, this goes up. So I just put it as P dash. This is also R. Now the distance it covered was the circumference of half of the circle. But displacement should be from P to P dash. This is the displacement. This is the shortest path that the circle can take, isn't it? Okay. So students, displacement, you don't have to think of how the circle will make a straight line. No. It's the shortest path between 2 points. Okay. So this point was here. One more. Okay. So this point was here. Now after one rotation, that point became on the top. So how easily can this point reach this point? It can just move like this. Okay. Yeah. So that is the displacement. So it displaces at an angle theta. Theta is the displacement. This is R. This is R. This is R. All these are R. Now how will I find out the displacement? So now this forms a triangle. Actually, this actually forms a triangle, right? And what will the distance be? What will this path be? What will this distance be? This distance is basically this much because it has moved this much. So isn't that the circumference of the circle? So half of the circle because half rotation. So this will be 2 pi r by 2. So this is pi r. Okay. So the length, distance is the circumference of the circle. Displacement is the hypotenuse of this triangle. So P dash, which is the hypotenuse, will be equal to 2r. Okay. P dash will be square root of pi r square is the base plus the height is r and r. The height is r and r. So it's going to be r plus r, 2r. So it will be 2r square. Okay. Now I will take the common terms outside. So this becomes pi square r square plus 4r square. So r square is common. R square plus r square, I can take it outside. So this becomes r square root of pi square plus 4. Sorry. Let me just look at the chat. Are you understanding this? So that is my displacement. Yes. Angle 180. So angle, how will I find angle? I just do tan theta. So what is tan theta? Opposite side by adjacent side. So tan theta will be, opposite side is what? 2r. Adjacent side is what? Pi r. So this will be 2 by pi. So the angle is going to be 2 by pi. Do you understand this? Okay. So I want you to understand this part. So this much is the distance. Okay. So that much has been covered on the ground. So that is why I just take pi r, circumference. The yellow lines are both the same. Okay. So the curved path and the straight yellow line, they're both the same. So the displacement is P to P dash. Are you understanding this? Where are all my students? Hey, what happened? Where did everybody go? Yes, is it clear? How is the angle 180 dear RXBTCC? I didn't understand. Quickly, can you let me know if this is clear to all of you? Yes, no. Okay, it's clear to Sai, Prarthana, RXBTCC. Is it clear? Do you understand why it's not 180? So those were some questions regarding distance and displacement. I hope that concept is thoroughly clear to you. Okay, now even in your sleep, if someone asks you what is displacement and what is distance, you should be able to say. Okay, I can give you one more, a small question. So imagine you have a running race, you start from point A, and the finishing line is also the point A itself. Okay, so you start from point A, you come back to point A. So the distance is what? The full circumference of the circle. Distance will be 2 pi r. Now what will the displacement be? Quickly let me know in the chat. What will the displacement be? So you start from point A, you come back to point B, it's a circular path. So distance is the total length of the circle, which is the circumference of the circle. Displacement should be how much? Yes. So watching it later, pause the video, tell me the answer. Let me know in the comments, okay? Yes, very good, Sai. It's 0. Why? Because you're at the same position. So what is displacement? Displacement is the shortest possible path an object can take. So see, it's the final point and the initial point are the same. So obviously displacement is 0 because the object does not have to move. Understand? Okay? Yes, Prarthana. Yes, Shivani. Very good. It is 0. So that's all that you need to know about distance and displacement. Now let's look at the next two terms that we saw under kinematics, which are speed and velocity. Okay? Students, are you able to hear a disturbance? If you're not, it's okay, we can continue. Is there a disturbance that you're able to hear? Yes? So there's a festival happening here and I can hear a lot of drums. Yes? Yeah, let me know if that's audible to you or not. Okay. Hello, Praveen, JK. Okay, let's look at speed. What is speed? Speed is basically the rate of change of distance with respect to time. Okay? Shifali is telling me you can't hear the disturbance. Is that what you're telling me? Yes? Yeah. Voice problem. Audible. I'm audible for Shipali, but my voice is breaking for Shivani. Okay, let me just continue. Then you can just stop me in between if there's a problem. Alright. Okay, Shivani. Thank you. Next is speed. What is speed? Speed is the rate of change of distance with time. Okay? Speed is distance by time. So if I am running 5 meters in 2 seconds, my speed is what? 5 by 2. If I am running 10 meters in 2 seconds, my speed is 10 by 2. So speed is basically my distance with respect to time. The amount of distance I cover with respect to time will give me speed. Whatever distance I cover. So the path does not matter. I can take a path like this. I can take a path like this. I can take a path like this. Whichever path I take, the amount of distance I cover in a certain amount of time will be speed. Okay? Now what is velocity? Velocity is displacement by time. Okay? What is velocity? It is displacement by time. Students, is there a voice issue? Can you quickly let me know if there is a voice issue? Students, there's some issue here. Okay. I'll just be back in 5 minutes. Oh, sorry. Now am I audible? I forgot to switch on my mic. Am I audible now? Shipali, can you let me know if I'm audible now? Oh, sorry. Sorry, now am I audible? Yeah, I think I'm audible now. Yes. Sorry for that. Okay, sorry for that. So let's continue. So what I was saying is speed is the amount of distance something travels in a certain amount of time, and velocity is displacement by time. Okay? Well, speed is distance by time, velocity is displacement by time. So the main difference between speed and velocity is what? I will let you know. But before that, do you know what a scalar quantity and a vector quantity is? A scalar quantity is a quantity that has only magnitude. It does not have any direction. But whereas a vector quantity has magnitude and direction. Okay? Yes, Sai, I will do basic to advanced level. I will do it in different classes. Okay? Because you have a lot of time. We have this whole year. So I will do it in 1.5 hour lectures each. Okay? And not a one shot video. So the disadvantage of a one shot video is then I'll have to go I'll have to go very fast. If I'm doing videos in parts, I can do a lot of examples. I can solve problems and I can make sure you're thorough with the concepts. Okay? Is that fine with all of you? So we'll do part by part. Yes? Okay, coming back to the topic. Scalar quantity is a quantity that has only magnitude. For example, temperature. If you have a fever, you measure your temperature. You say it is 28 degrees Celsius. Whichever direction, it does not matter. Your weight. Your weight also, you only measure magnitude. So similarly, for distance, you only measure the length. You don't measure in whichever direction. See, from A to B, you can move like this, you can move like this, you can move like this. It does not matter. The direction does not matter. Only the length of the path matters. So obviously, speed is what? Speed is a scalar quantity. Because in speed, the direction does not matter. Distance does not have direction. Time does not have direction. So speed also need not have direction. So it is a scalar. But if you look at velocity, velocity is displacement by time. And displacement has a specific direction. Displacement is the shortest possible path and it can be only in that particular direction. So displacement has a specific path. So obviously displacement is a vector quantity. So if displacement is a vector quantity, velocity should also be a vector quantity. So we have velocity also a vector quantity. So another difference between speed and velocity is speed with direction. Okay, so imagine I am running a race. Okay, so I am running a race. My speed is 5 meters per second. No direction. But what is my velocity? 5 meters per second in the forward direction is my velocity. So that's the difference between speed and velocity. I'll give you another example. Let's say A to B, you are walking, okay, and your speed is 5 meters per second. Even if you walk front, back, side, your speed is always 5. But your velocity will be 5 meters per second forward. Okay. Now, if you have two people, okay, A to B and B to A, they're walking the same distance, same time, okay, but one person is walking forward, one person is walking backward. They both have the same speed of 5 meters per second, but they both have different velocities. Why? Because one person is moving up, the other person is moving down. They are moving in two different directions. So even though if they have same speed, they will have different velocities because they are moving in different directions. Do you understand that? That is because velocity is a scalar. Okay? Okay? So, speed is scalar, velocity is vector, speed depends on distance, velocity depends on displacement. Speed, the direction is not required. For velocities, direction is very essential. Okay? Speed can be positive or zero. When is the speed zero? When you're not moving. Otherwise, it's positive. But velocity can be positive, negative or zero. Okay? See, when you're driving your car, you're looking at the speed, not the velocity, because you don't look at the direction. In whichever direction you're driving, your speedometer shows you the speed. So it can either be 0. If your car is switched off, it will be 0. If your car keeps moving, it will move in different directions. But what is velocity going to be? Velocity can be positive, negative, or 0. How can velocity be negative? So let's say, as I said, someone moves from A to B with a velocity of 5 meters per second. Now, if he is moving from B to A with the same, distance, displacement, time, and all that, his velocity is now minus 5 meters per second. Why? Because he is moving in the opposite direction. Okay? So, velocity can be positive, negative, or 0, depending on the direction. Is this part clear to all of you? Yes? No? Okay. Next important terms that we have to look at is average speed, instantaneous speed, average velocity, and instantaneous velocity. So what is average speed? Average speed is when average. Okay. Yeah. Nobody is telling me anything in the chat. Is this clear to you? Not clear? Yes, Prarthana, very good. Vector has both magnitude and direction. Okay, so average speed is what? Average speed is the total distance divided by the total time taken. So let's say you move from A all the way till D. So in between till B you have a different distance till C. So many distances. Okay, from A to B imagine you take 2 seconds. From B to C imagine you take 3 seconds. From C to D you take 5 seconds. So all of this total distance divided by total time will give you the average speed. So simply speed is speed at one point. Average speed is the total speed, the total distance by total time. Now what is instantaneous speed? Instantaneous speed is also the speed at one particular instance. Okay, so for example, when you're driving, okay, imagine your dad is driving or your mom is driving and you're sitting next to your mom or dad. And then Mom, at what speed you're going? And you look at the speedometer. At that point, what speed you see? That is the instantaneous speed. The speed at one particular instant. Okay. Now, same thing for velocity also. What is average velocity? It is total displacement by time. If average, yes, you have to learn integration also. We'll come to that. Okay. Yeah. So, average velocity is total displacement by total time. Average speed was total distance by total time. And instantaneous velocity is just like instantaneous speed, but here it is the velocity at one particular instance. Okay. So it includes both direction and speed. Okay. So average speed should always be greater than or equal to average velocity. Why? So the average speed is total distance by total time. Distance is always greater than or equal to displacement, isn't it? So distance by time should always be greater than or equal to displacement by time. So average speed, distance by time is average speed. Average speed should also be greater than or equal to average velocity. Okay? Do you understand? We already learned distance should always be greater than or equal to displacement. So if distance, time is the same for both, so average speed should also be greater than or equal to average velocity. Okay, let's look at a question regarding average speed and average velocity. A girl walks 3 kilometers north. Okay, so the girl walks 3 kilometers north. Okay. Yeah, the girl walks 3 kilometers north. She walks 4 kilometers east. She walks 4 kilometers east. The time taken is 2 hours. What is the total distance? The total distance is obviously 4 plus 3, which is 7. No doubt about it. Total distance is 7 kilometers. So time taken is 2 hours. So the total speed, the average speed is what? Average speed is total distance by total time. So average speed is total distance by total time. So 7 by 2, which is 3.5. Now let's find out the average velocity. So what is average velocity? Average velocity is total displacement by total time. Now what is my displacement? So if this is point A, this is point B, the shortest possible path will be this. Yes, it's this, the shortest possible path. So this path is the hypotenuse. So hypotenuse square is equal to 3 square plus 4 square. So hypotenuse is equal to square root of 3 square plus 4 square. So you will get 5 kilometers. Okay. So your total displacement is 5. Time is again 2. So average velocity will be 5 by 2, which is 2.5. Okay. Do you see the difference? Average speed was 3.5, but average velocity is only 2.5. Do you understand this question? Prarthana Kulkarni, 5. Yes, 5 is the displacement. But what is average velocity? Are you getting 2.5? Is this clear to all of you? Yes, you get displacement by Pythagoras theorem. Yes, very good. I can't read your name, okay? But yeah. We will not do graphs today, Sai, because we will finish till acceleration. In the next class, we'll start with graphs. Okay? Because I don't want the session to be more than 1.5 hours. Alright. Let's go. Let's look at the next question. A man goes from point A to point B. Okay? A man goes from point A to point B. His speed is V1. Now he returns back from point B to point A. From point B to point A, he returns back. His speed is V2. Okay? So in this direction, the speed is V1. In this direction, the speed is V2. Find out the average speed and average velocity. So to find out average speed and average velocity, first thing you should do is you should find out distance and displacement. Okay? Yes, Rockstar. I remember you. Rocker, I used to call Rocker Rockstar. Now let's first find out the total distance. What is the total distance? So if the distance one way is d, the distance backwards is also d. So the total distance will be d plus d, which is 2d. Okay? D plus d, which is 2d. Now, what is the time taken? Time taken to move from A to B will be what? The distance d divided by speed v1. Now, the time taken t2 for B to A will be again distance d divided by the speed v2. So, what is the total time? Total time is t1 plus t2. Okay. So, total time is t1 plus t2, which is what? D by v1 plus d by v2. Okay. Now let's find out. Now I have the distance, I have the time. So let me find out the average speed. Average speed is total distance. Total distance is 2d divided by total time. So d by v1 plus d by v2. Okay. Now you can cancel off all the d's. What remains? You will get 2 divided by 1 by v1 plus 1 by v2. Now if you do the math, you will get 2v1 v2 divided by v1 plus v2. Okay. Now for your exam, you might get numbers here. Instead of v1 and v2, you might get numbers. Same steps. Okay. So this is average speed. Now how will I find average velocity? To find average velocity, I need to find out the total displacement. Now you tell me, what would my displacement be? Yes, displacement will be 0. Why? Because in the forward direction and then it comes back. So what is the shortest path? Shortest path is staying in the initial position itself. So displacement is 0. So what is my average velocity? What is my average velocity? It is 0. Displacement is 0. Time is t. So this is 0. Okay? Is this question clear to all of you? Hello, Manjunath. Prarthana, ma'am, how? What do you want to know, Prarthana? How, as in which step is you? Which step? Is it average speed or average velocity part? Yes, Prarthana, you also put 0. So what is your doubt, dear? Praveen, I didn't have my dinner. I was at rest teaching you. So when I will have my dinner after the class. Okay. Yes, this is only for 2 equal distance. Yes. Yes, Sai, this is only for 2 equal distance. So in the question, it is equal distance. Speed part you didn't understand. Hello, Gaudru. Speed part. Okay, I'll explain the speed part once again for Prarthana. So you move from A to B. Okay. So you move from A to B and then you come back. Okay. The speed, first speed is V1, the second speed is V2. The time taken for both is T1 and then T2. So distance covered is the same. So this is D, this is D. So what is the total distance? D plus D, 2D. Yes, 2D is the total distance. Now what about the time? So here the time T1 will be what? V1 by D. Here the time T2 will be V2 by D. So the total time taken for it to go to this point and then come back is T1 plus T2. And what is T1 plus T2? Sorry, here I put it the other way around. This is D by V1, no? D by V1 and D by V2. So what is the total time? T1 plus T2. So D by V1 plus D by V2. Now what is speed? Total distance by total time. Total distance is 2D. Total time is D by V1 plus D by V2. You cancel all the T's. You do the math. You will get the value of speed. Okay? Yes. Very easy. Let's do one more question. Okay? So what is this question? This is for class 11. Archita. So students, you can look at the thumbnail. Okay, on the thumbnail is written what I'm going to discuss and what the topic is. It's clearly written first PUC. First PUC is class 11. Okay. Second PUC is class 12. Okay. Yeah. So this question, next question. A man covers the first half of a journey at a speed of V1 and the second half at a speed of V2. Okay. So he covers the first half at a speed of V1, second half at a speed of V2. So, yeah, let's look at that question. So, first half, he covers it at a speed of V1. Second half, he covers it at a speed of V2. So, let's say the distance is the same for both. So, what is the time? D by V1 and the time here is D by V2. The time taken for both of this is D by V1 and D by V2. So time for first half is D by V1, time for second half is D by V2. Find out the average speed. What is the average speed? Total distance. Total distance is 2D. The whole divided by same thing. Total time. Total time is T, which is D by V1 plus D by V2. Now solve it. Do the math. You should get 2V1, V1 plus V2. The answer is the same. But the question is two different things. Here what happens? A man covers the first half of a journey at speed V1 and second half at speed V2. Is this clear to all of you? Okay? Yes? No? Yes. That's one basic quality every teacher should have, Archita. Yeah? So please send this to all your friends. Let them know that there's a teacher who's teaching this, okay? Yeah? So spread it to people. That's the only thing I want. I want people to know, and all students should get good explanation. They shouldn't just mug up textbooks and go write it for the exam. They should know what actually happens, right? Yeah. So if I'm able to do that, I'll be the happiest person. Okay. One more last question. I think this is the last question. Yes, this is the last question. Okay. A man covers three equal distances. A man covers three equal distances at speeds v1, v2, at speeds v1, v2 and v3 respectively. Find the average speed of the entire journey. Okay. So what happens? Same thing but at three different speeds. v1, v2, v3. So speed will be d, d, d. So total time will be d by v1, d by v2 and d by v3. So this I want all of you to do as homework and let me know in the chats. Okay, the final answer I want you to let me know in the chats. Yes? So what is the total average speed? Yeah? Okay? Is that clear to all of you? I've just scrolled through and I've shown you the answer. So if you go back to the video and quickly pause it, you'll get it, but I trust you. I want you to solve it and quickly let me know. Not quickly after the class, I want you to let me know in the chat. Shipali has already solved it. Very good, Shipali. Thank you, Archita. So it would be a great help. I mean, if you can all send this to all your class groups and tell them to follow the first few lectures. So this is just part 1 of this chapter, Motion in a Straight Line. I'll be doing parts, part by part. Okay? Yes, Shipali, very good, very good. Okay? I don't teach NEET, dear. I teach KCET and I teach, I mean, even for NEET, I won't be practicing questions, but the concept is going to be the same. Okay, so every content I teach, I'm teaching it in terms of your PU exam as well as for a competitive exam, like JEE, NEET, KCET, whatever. Okay, so whatever theory you want, you can get it from here. Questions also we will be doing, but not initially. Okay. RXB TCC has depression. How to overcome depression? So the main trick to overcome depression is keep yourself engaged. Okay, so keep watching classes, keep studying, keep doing things. Don't sit simply and listen to all these sad songs and be depressed. Okay, keep yourself engaged. Go out, play with your friends, have fun. At this age, what depression? Okay, let's just finish this off. Last part of the class is acceleration. So what is acceleration? Acceleration is the rate of change of velocity of an object with time. Okay, so when an object changes its the way it moves, it's called acceleration. It is the rate of change of velocity of an object with respect to time. So imagine you drive your car. So initially you're at point A, until point B you drive at a speed of 20 meters per second. From B to C, you drive at a speed of 60 meters per second. So, your speed increased from 20 to 60. Now, if this happened in an interval of, let's say this happened in an interval of 50 seconds. Okay? Okay? So, if this happens at an interval of 50 seconds, then what is my acceleration? Then my acceleration is the difference in my speed or difference in my velocity divided by the time I took. Okay, so acceleration is the change of velocity by how much the velocity changes in a certain amount of time. Okay, so the formula is the final velocity minus initial velocity by time taken. Now imagine I have point A, point B, point C, point D. So I'm going from Bengaluru to, let's say, Kolar. Okay. So initially I go with the speed of 10 meter per second. After some time also I go with the speed of 10 meter. Even after some time I go with the speed of 10 meter per second. So my speed is the same. I mean velocity is the same. So what happens? Zero acceleration. because the velocity is not changing. Okay, so acceleration is when velocity changes with respect to time. Is this clear? Okay. And what is the unit of acceleration? The unit of acceleration is meter per second square. How do I get that? This is velocity by time. The unit of velocity is meter per second. The whole divided by second. So this becomes meter per second square. Okay? Yes? Yes. I think we will wind up today's class with that. In the next class, we will look at what are the different kinds of motion and the equations of kinematics and graphs and all of that. Okay? And really sorry, Prarthana, I know I shouldn't do that. That will break the flow of the class, right? Yes, I understand. Okay? Next class, I'll make sure I don't do that. Is this much clear to all of you? Any doubts? Okay, one more thing. So if something is speeding up, it'll have a positive acceleration. If something is slowing down, it'll have a negative acceleration. So when I'm throwing a ball up, what happens? It goes up with an acceleration. If it comes down with a deceleration. Okay? Yes, is this much clear to all of you? So I think we will wind up today's session with this much. So these concepts, you might feel that they're very easy. What is that? Distance, displacement, speed, velocity, acceleration, one full class. What, ma'am? All the questions that we did, okay, they're all application based questions. You are able to answer them because we practice them. They're very important. Okay. So in the next class, we will look at more content. We will look at the time graphs, equations of kinematics, and all of that. Is that clear? Can you all just let me know in the chats? Okay, RXBTC put fire. Okay, others, how is the class? So please let me know in the comments, students. I'll be leaving now. Let's see you with another video in the next class. So the live chat will end now. Please let me know in the comments on how the class was. Okay? Bye-bye. See you all in the next class and see all of your friends in the next class. You should send this to all your friends and make sure all your friends come. Subscribe, like, and share this to all your friends. Okay, bye-bye.